Hi folks, so this is question 8. So all students do a maths exam in first year, so the results is in integer values. Okay, so it's normally distributed. So when it's normally distributed, we can put it onto this kind of a curve anyway. So the mean there is 176 marks. So the standard deviation is 36. So the top 10% of students will go forward to a county maths exam. So the top 10% then have to be right up at the top of it up here. So they have to be the ones in here. So our Z score is down here anyway, so this is what we're interested in. Now remember, you can only look back for less than or equal to Z. So for less than or equal to Z, we're looking, so if in the red part there, that's going to be 10% or 0.1. So then what I shaded in the black here has to be 0.9. So we're going to look up a Z score then for 0.9. So if you go to your Z scores in your log tables, and I think it's on the second page of it, you'll see this then. So we're looking for one that's 0.9, or the closest one to that would be 0.9. So I think it's going to be this one here. So and that's the closest one there, that's to 0.9. So it's 1.28. So 1.28 is our value then. So what do we let that equal to then? So remember that our kind of formula for Z score, so that's going to be whatever our value is, and this is what we want. This is the minimum score then. This is what the minimum amount that they need to get above, because we've looked up the Z score for 90%, or for, yeah, and for 10%. So minus mu all over standard deviation, and we know what mu is and we know what the standard deviation is. So mu is just the 176, that's the mean, over 36, because 36 is the standard deviation. It gives it to us in the question, and we let that equal to 1.28, and then we just have to go and solve. So x minus 176 is equal to, we multiplied it 36, so we get 46.08, and then we just need to add on the 176. So we should get x is equal to 222.08. So if you think about it, you can't really get 222.08 of a mark. You can't get 0.08 of a mark. So they would need to get above the 223 then. So 223. So marks. So that's the first part. Right, so for the second part then, I'll just draw this out again. The normal distribution. So our mean is here, so that's the 176, so that's from the first bit. So it's in between 165 and 210, so you'll notice that 165 is less than 176, so we'll say that 165 is there, and we'll say 210 then is up here somewhere, so 210. So really we're looking for what's the area in between those two. So we can come up with a Z score for both of them anyway. So for the first one, it would be 165 take away mu, which is 176, and it's all over the standard deviation, which is 36. And then for the other one, it's 210 take away 176 all over the standard deviation, which is 36. And then you can put those two in the calculator and you'll get minus 0.31 and 0.94. So if you think about that on the normal distribution, then if 0 is here, so then minus 0.31 is there and 0.94 would be there. So what we want to do then is we want to take the area. So remember, we have to take area from the left hand side back to 0 or back to the start. So we want to take the area of all of that up to the line there, up to the 0.94. We want to take the area of all that, and then we want to take away this area because we don't want that. We only want the area that's between the two lines, really. So we're doing one, really take away the other, and that'll give us what we want then inside. So it'll be something like this then. So it'll be the probability of Z being less than or equal to 0.94, and then we're taking away the other one. We're taking away the minus 0.31. But remember, you can't get a negative, so it'll be probability that it'll be 1 minus the probability of Z being less than or equal to 0.31. So that'll work out because we're just taking the minus out of it. It's the rest of it basically. So if you look up the Z score then for 0.94, so go to 0.9 down the left hand side there, and then go across the top to 4, so we get 0.8264 there. And then this will be minus, so it's kind of minus 1 plus, so it'll be minus 1 plus, and then it's the Z score of 0.31. So 0.31, so you go down to 0.3 on the left hand side and then to 1, so you get 0.6217, so 0.6217. So that's almost it then. We just calculate all that, and you can just use calculator, and you'll get 0.4481, and that's the same thing as 44.81%. So that's it for that part. Right, so for the next part then, we just have to find the Z, or find the test statistic, or the Z score. So there's a formula for that anyway. So Z equals X bar minus mu all over standard deviation over root of n. Alright, so X bar in this, so you're just picking out what they are then. So it's a news report claiming that 6-year students studied an average of 21 hours per week. So therefore mu has to be the 21. Yeah, so that's what it claims to be, an average of 21 hours per week. There's 60 students surveyed, so then n has to be 60. N is always the amount of people in the survey. Chosen at random from different schools. It found an average study time was 19.8. So the 19.8, then that's going to be your X bar, so that's within the survey then. And then there's just one other thing, the standard deviation of the sample. Yes, that's going to be 5.2. Yeah, so that's within the sample as well. So it's just putting all those things in, then we know what they all are. So you just have to put in 19.8 minus 21 over standard deviation, which is 5.2, over square root of 60. And you can just go put all that in together then into the calculator, and you should get, you get a minus actually, so minus 1.7 0.875, and I'm rounding that off as well, so that's a recurrent decimal. So that's it. And then the next part, we're going to have to do something with it. So we have to find the p-value of this test statistic. So comment on what can be concluded from its value in a two-tailed hypothesis test at 5% level of significance in relation to the news report claim. Right, so if you think about our normal distribution again, so if 0 is there, so 1.96 then, because it's a 5% level of significance. So our test statistic from the first part was minus 1.7875, so we'll round it up to 1.79. So we'll put in 1.79 then. So minus 1.79 wouldn't be quite as far as the 1.96, so it'll be here. So that will be minus 1.79, and it's a two-tailed hypothesis test. So two-tailed means that we've got to test over here as well. So 1.79. So it's everything then that's inside there. So we want to look up the probability that Z is less than or equal to minus 1.79, and remember again, we can't do minus, therefore we're going to have to do 1 minus the probability. Yeah, we can't look up the Z score for minus in our tables, so we're going to have to look up probability of 1 minus the probability of Z is less than or equal to 1.79, so of positive 1.79. So if we go back to our tables again, and you'll have to go down here then. So 1.79 then, so if you go down the left hand side to 1.7 and across the top to 9, so it's the furthest one over there, so we get 0.9633. So it'll be 1 minus 0.9633, and then we just need to calculate that, so it'll be 0.0367. Now remember that we need to find for the two sides, so therefore you're going to have to times that by 2 there. So if you do 0.0367 times by 2, we get 0.0734. So that then is the same thing as 7.34%, and then that is clearly, so if you're testing for the 5% level of significance, 7.34 is clearly above 5%. So that's basically it tested. We have to conclude then, so what we're going to conclude then is that because it's above, then the news report has to be right, basically. So news report is correct. And you will have to write a little bit more than that in the exam. So you'd have to go and say that, you know, the news report that claimed that 6th-year students in Ireland studied an average of 21 hours per week outside of class time is correct, that there's not enough evidence to suggest to reject the claim. So based on our test statistic. So the news report is correct, not enough evidence to reject claim. So that's it. It's very bad handwriting as well, but So we've only got, we'll run the part C anyway. And so we're back to probability here. So the school caretaker has a box with 23 room keys in it. So 12 of the keys are for the general classroom. So general. Science labs. And the others then are office. So if you think about the probability then of a general, that when you take, if you pick one out of that box, and the probability that it's a general classroom key has to be just 12 over all of them, so 23. The probability that it's a science lab is just 6 out of 23. And the probability that it's an office is 5 out of 23. So they're the probabilities of when you take the first one out, basically. So what they're asking us for here is for the fourth one drawn. So we're going to multiply each of them. So for the first one, second one, third one, and fourth one. So it's not a bad question, really. So the first one, all you want for the first one is that it's not an office key. So if it's not an office key, think about how many of them are not office keys. Well, there's 18 of them because it's the 12 plus the 6. So 18 out of 23. That's what you want for the first one. You want it not to be an office key. It can't be an office key for what you want to work. The next one then, you want the same thing, but remember there's one gone now. So there's one that's not an office key gone out of it. So therefore there's only 17 left. And there's only 22 left altogether. For the third one then, it's the same thing. It's 16 out of 21. So we're just reducing it down again. So remember there's another one gone, another non-office key gone. And then for the fourth one, we actually want an office key because we want the fourth key drawn to be an office key. So therefore for that to work, there's 5 office keys left because there hasn't been one gone yet. So it's 5 out of, and think about how many there's left then. There's one other one gone there in the last one, so therefore there's only 20 left. So 5 out of 20. So you do 18 over 23 multiplied by 17 over 22 multiplied by 16 over 21 multiplied by 5 over 20, and then that should give us an answer. So we get 0.1152. And they actually wanted us to give our answer to 4 decimal places there, so we're done. So that's it, 0.1152. Okay, all the keys are returned to the box then. Then 3 keys are drawn at random from the box, one after the other without replacement. What is the probability that one of them is for a general classroom, one is for a science lab, and one is for an office? Right, so let's think about all the kind of combinations we could have then. So when you're picking out 3, you could get, so I think there's going to be 6 altogether. You could get a classroom, science, and an office. You could get a classroom, an office, and a science lab. Then you could get, so we'll put S first then, you could get science lab and an office and a classroom. Or we could get a science lab, a classroom, and an office. And then there's 2 more, so it's if the office is first. So if you get an office, a classroom, and a science lab, or an office, a science lab, and a classroom. So there's 6 possibilities there that you could get what you want. So we're going to take the probability of all of them and add them all together. So for the first one, probability that you get a classroom key first would be so classroom. I'm forgetting here. So 12 of the keys are for general classroom. So that would be 12 out of 23 times by science lab. How many was there science lab? sorry, 6 for a science lab. So remember, it's out of 22 then, and then there was 5 office, so 5 out of 21. If it was classroom, office and science, that would be 12 over 23 times by 5 over 21 times by 6 over 22. If it was a science lab first, it would be 6 over 22 times by office next is 5 over 21, sorry 23, 22 and 12 over 21, sorry I shouldn't, so we should be going 23, 22, 21 all the time, obviously, because the second and third one there's one gone. So you can see what I'm doing here each time, so you could kind of keep going like that. But what you should realize is that it's the same number numbers that's on top each time. It's 12, 6 and 5 that you're multiplying each time on top. It's just that they're rearranged around a little bit. But it doesn't matter, it'll still be the same thing that you'll get on top each time. And on the bottom, it's always 23, 22, 21 that's on the bottom there. So 23, 22, 21 for each of the 6. So all we really need to do is we need to work it out for one of them, and then you can just times it by 6. It's just a little shortcut. So, or what you do is just you do 12 over 23 times 6 over 22 times 5 over 21, and then times that by 6, and just do all of it together on the calculator. So when you do that, then you should get 0.2033, and that's to 4 decimal places again. That's what they wanted in the question, so that's it, and then that's everything for that question.